we're looking at the menus for my Fujifilm X-T32. If you're using something different, then your settings will look a little bit different. But if I go into the menu here, and you see I'm on the image quality section, these are all the values that I'm looking at. I'm looking at the film simulation, so here's all my options here. I've got grain, chrome, white balance, my tonal curve, all of this, right? Now, if I keep going down, get onto the third page, I can see select custom setting or edit custom settings. So you can see here that I've got 7 different custom settings that I can save, and I've named each one for the respective recipe. So this is the main issue that we're working with, right? So the challenge is that Fujifilm writes the film simulation to the EXIF and the image metadata, but they don't save the recipe itself. So if all of these recipes are based on the classic Chrome simulation, there's nothing saved to the metadata that delineates the exact recipe that was used. So that's where our problem comes in, and that's what we're going to learn how to solve today. Okay, before we get into this, I did want to point out that all the source code that we're going to be going through is available for you at my GitHub site. It's github.com/photomonkey/exif This is the only repository I have out here, so it should be pretty simple to find. There's a quick README here. The main folder that you'll be interested in to work through this is the basic folder. There is an advanced session coming, so stay tuned for that. But everything that's out here that we'll talk about is going to be in this repo. And if I make any tweaks or changes, I'll be sure to update that. So go ahead and bookmark this and come back to it periodically, and we'll see if things change. With that, let's get on with the show. Okay, so let me set the stage a little bit for you. I drove out to a city about an hour or so away and ended up using 3 different recipes. You can see here I've got my screen up, I've got the images, they're all shot in Fuji RAW, and I've created an original folder so that I can get back to it as we're playing around with this. I wanted to talk to you about the Exiftool itself, just to give you an overview. I'm not going to dive real deep into this. I have up here on my screen the Exiftool in my browser, so you can go to exiftool.org, and that'll have all the main information you need to get about downloading it and installing it, whether you're on Windows or Mac. I'm running this on a Mac, so some of the commands I tell you might be a little bit different if you're on the Windows platform. This would also work if you have Windows subsystem for Linux or WSL, and you could install the Linux version of this, and that would probably have a little bit more parity to what I'm doing on the Mac side. I just wanted to give you a quick overview as to some of the things that you can do with it. Let's start off with Exiftool itself. We'll clear the screen here, and we'll just run Exiftool. And if you do that, then you'll get the help file and you can page through it. I'm using the F key here to move forward, and Q to quit. So what you're going to do is you're going to use Exiftool, the command, and then pass it a series of flags that you're interested in, and either pass it a file name or list of file names and or a directory. So let's just say I want to see everything in this directory, and I'll just use the dot, say, run an Exiftool on everything in my current directory, and you can see it's going through. Okay, so let's make this a little bit more user-friendly. And we'll just grab one of these images here and pass that file name. And now I get the data only for that file. And you can see it's got a lot of information, but you can also see that everything's out of order. There doesn't seem to be a rhyme or reason, so it might make it difficult to find exactly what you're looking for. So let's use the sort flag. And now I get everything sorted alphabetically. So this makes it a lot easier. And when we get into actually looking for the values or setting the values, something you'll notice is there's no spacing. So if we look at raw exposure bias, for example, the actual field name has spaces, but the tool uses no spaces. So it would be raw exposure bias, one single word. Now, we've talked about the metadata and how there are different sections of metadata, right? You have EXIF, you have IPTC, you may have custom manufacturer information, which is what Fuji uses to keep track of the simulations and things like that. So let's see what those groups are. We'll do the same file here, and this time we're going to pass it a little g. And now notice what it's done is it's added column headings. So now we can see how the fields are grouped. So if we scroll back up, you can see here's maker notes. So everything in this section is all the information that Fujifilm has written specifically to track their information that they're interested in. So let's look at one other thing. I'll clear the screen. I'm doing Command or Control L. We'll just go back, make that a big G. And now you get the same data, only rather than having the header, you just have this tag before the data element. Now, let's say you want to know something particular about this file. For example, something that we want to know probably is, let's look at the film mode, right? The film mode is going to be the key thing. That's the simulation. So you use a dash to denote the field name, and we want film mode. Notice that it doesn't have to be case sensitive here, and we'll just do everything. So now we can see that we've got a mix here of classic negative, and notice that Astia is not just Astia, right? So this is one of those things where as you go through the simulations, Velvia is another one that jumps to mind. You might want to do this when you take pictures and you're starting to work through this yourself, to do this just to see, take a picture with each of the simulations to get the exact name. Eterna Bleach Bypass is another one that isn't quite what you would think it is. Now, notice that some of these are empty, right? So they don't always have anything. And that's because, and I don't know the reasoning behind this, but if you use a black and white simulation, either Acros or monochrome, for some reason that's not saved. So if it doesn't have a film sim, then you know that it's one of those two. Now, from there, you'll have to go in and look at another field, which is actually saturation. So if we look at saturation, there you go. So you can see, I know for a fact that the black and white filter I used was monochrome green. And so I know that looking at these, that's what anything with a black and white green filter is going to be my Leica M10 monochrome recipe. So that's something to be aware of. There are a few nuances like that where you think you'd be looking at the saturation, but you end up having to look at another field. And white balance is another one, and we'll look at that. In fact, let's just do that right now. Notice how we have a lot of them in here that say Kelvin. So this tells me that I used a specific color temperature, And so now in order to figure out what that color temperature was, then I would have to look at the color temperature. Now you see I've got two different values. I have, again, I had three recipes. So one of them is obviously set to 5500 Kelvin and the other one is set to 10,000. And just off the top of my head, because I put these recipes in the camera, I know that 10,000 also equates to the monochrome. Now I can also stack and request several fields together. So let's say I wanted to do white balance. Let's do film mode and white balance. Why not? And now it'll list out all of those values if it has it, if it's populated. So you can see here on the 1591 file, I've got classic negative. It was shot with a fixed Kelvin value, and that value is 5500. So this is how we're going to dig into the metadata to help identify our actual files. And this is what's going to give us the ability to figure out what the recipe was and record that. Now, the way we're going to do that is, and this is up to you, you can feel free to change this. I went through and picked two particular fields that aren't used, at least not by me. So I feel pretty confident that I can use them and it's not going to mess anything up. And I'm actually using two IPTC fields. The first one is the original transmission reference, and that's where I'm going to write the actual recipe name. And then I'm going to use the special instructions section or tag to record the URL. So I want to be able to go back to it later and not hunt down a spreadsheet that might have that information. If I embed it directly in the file, I can just come in here, look the value, and not only know the recipe, but also where it's sourced from. Now let's say I want to do a group of information. So we've looked at how we can see everything. We can see individual tags. So now let's look at a group. And we can do that by passing the name of the group. So if we want to know the EXIF information, for example, we'll tell it we want all the fields out of the EXIF group. And I accidentally did all of the files. So let me just grab one. We'll do that again. And now we only get the EXIF for that particular file. Now, we saw that Fuji stores their data in maker's notes. You can also get to it by passing Fujifilm. And now you see all of the manufacturer-specific information that's stored. So this is a good way if you're trying to localize what you're looking at, then you can look at just that group. And just to show that there's nothing in the IPT section that we'll be editing, we'll look at everything. And you can see there's not a single bit of IPTC data in any of the files. So I switched over from iTerm, my command line tool, to Visual Studio Code. You can do this with any text editor. The key is you just need something that you can create a text file in. So the way we're going to facilitate all of this today is through a bash script. And bash is, we'll say, a language. It's really a shell, which I don't want to get into at this point, but it gives me the ability to write scripts. And so what I'm going to do is This will allow me to automate the things that I was just doing from the command line manually. I could sit there, type this all out, and manually manipulate all these images. But a better way, a more reusable way, is to do this as a script. So that's what we're going to do here. And you can see here I've got on my screen a framework, and this is what we're going to start building out in the next steps. So this is one of those where let's just take it with a grain of salt, accept what it is. Don't worry too much about what it's doing at this point. Um, line 1 just sets this up as being a bash script, and then lines 5 through 9 say take every file, every image, or basically in real terms, take every command line argument that you pass to this script and do something to it. And whatever falls between lines 7, really between lines 6 and 9, is going to be executed. So if I pass this script 5 different files, it's going to echo the file name of each one of those. And that's really all we have to worry about at this point, and we'll start building it out. Okay, so you can see my file names here. I'm keeping this pretty straightforward for you so you can follow the progression. So now we're on the second step, and that's adding a simple body. All I've done is replace that bit of code that was echoing the file name, and now we're actually going to call the Exiftool application itself and update the values. So I remember I said that we were going to change the original transmission reference and special instructions. And you can see here that ASCII Pops is one of the recipes that I used for this series of images. And I've listed the actual URL where I found that. Now, a couple of things here that we didn't talk about before. I'm going to add the overwrite original or overwrite underscore original flag. And what that's going to do is basically replace the original image with my modified version. And the reason I want to do that is really to conserve disk space. As a safety measure, I could leave this off and you would see when it runs, there's actually a copy of the original and it has an underscore original bit added to the file name. But I basically doubled the amount of storage I need. So I've done this enough that I trust the process and I'm willing to take the risk of overwriting my original image. Also because it's still on my memory card, so if I really screw things up, I can go back and get the source image. Now, the next piece here is the -p, and this is going to preserve the original date and file time. I shot this series of images several days ago, so I want to make sure that I keep that date and time as opposed to the date and time when I'm actually running it to update this value. I'm passing the $F because that's representing the name of the file, and I'm putting it in quotations because within Bash we're going to do something called expansion. And if you have long file names or file names with spaces in them, for example, if you don't put it in quotes, then it's not going to expand properly. So if we review what we said, we're going to take every command line argument. So we'll just say every image file that we pass to this script. It's going to be saved as a value of f. This is just a variable name that we'll reuse. One thing I need to do is I need to actually pass the full path to Exiftool. I've discovered that if you just use Exiftool, even if it's in your search path, it doesn't always get picked up. So I put the explicit path and that seems to solve the problem. Again, I'm going to set these two values and I'm going to overwrite the original, preserve the original date timestamp, and I'm going to run it on this file. Now, if I go to the command line, there we go, you'll notice that the script that we're working on is white. And the reason for that is because it's not executable. There is no way that I can run this script. So if you look at all of the red scripts, they have this RWX or R-X. And so I won't get into Linux file permissions, but it basically means read, write, or execute. if it doesn't have the X, I can't execute it, which means I can't run it. So I want to run this script. So I'm going to change the mode using the chmod, and I'm going to add the X bit to this script. And now you can see every script in here is read, write, and executable. This is a cool thing that you can do to test this and run it, and you can just drag files into your terminal. So this is my script. I probably should have done this without spaces because it looks a little funky. I'm going to go over to Finder. These are the images that I shot, and I just did this we'll just do this for, let's say 10 of them. All right, and we're going to drag these over, drop them, and now it's added the full path to all of these. I'll hit enter, and now it's going through and it's updating every single file that I passed it. Now, if you remember, the last time we looked at the IPTC data, there was nothing there, right? And so if we look at that again, those are in pictures, Exiftool. There you go. And now you can see that we've written special instructions and we've written the transmission reference. Just right there, we've satisfied the basic steps, right? We have the ability to go through however many images. We could have just selected the ones that this recipe applies to and drag those over, but let's make this a little bit more flexible. Okay, so now it's time to build upon what we've already got. We've got a framework that lets us write metadata to our images. But now let's look at the 3 recipes that I actually used for this image set. So jumping ahead a little bit, you can see I used Dreamland, which, by the way, is my go-to recipe for anything vintage. If you're shooting old, rusty vintage cars, rundown, dilapidated buildings, I don't know why, but at least for me, this is my go-to recipe for that. I also shot a few of them with Astia Pops, and then I was also trying out the Leica M10 monochrome recipes. So what I've done here is used some basic programming tools, and one of those is we've already got the for loop, which just lets us loop through and iterate through a list of items and do something to it. Now I need to make a decision about each of those images that I'm passing. Because I know that the way I set this up, right, so I did some thinking ahead of time, I did some planning before I went out, and I said, I'm going to use these recipes, right? So I know I'm limited to just 3 out of the 7 recipes. If I potentially used them all, then I would come in here and I would put a use case in for every scenario. But I know that everything in my camera is a specific simulation. I don't have like 7 different classic Chrome recipes. So that's where planning ahead makes this easier and more acceptable. But I need to know what that simulation is. In our previous examples, we looked at the film mode, and so that's what I'm doing here on line 8. I'm getting the film mode that was used for a particular image. In this case, the images that I passed into the script. And so just like F on line 5 is a variable, so is sim. And so this is just some syntax you can accept. I don't want to get too deep into it, but basically the dollar sign says to execute this and execute whatever is in the parentheses. So that this is whatever's in parentheses, and assign that to the variable sim. And so I'm using Exiftool, I'm grabbing film mode, and what's new here is the -S3. What that's going to do is get me just the data value. I already know I'm getting film mode, I don't need the label with it. So if I show that to you, let's look here, let's see what my images are. Exiftool film mode. And it tells me classic negative. Again, I don't care about film mode here because I already know what it is. So if I change this to -S3, it only gives me the sim. So now that I know what the sim is, I'm going to use this case statement, and so the syntax is case whatever I'm looking for, what is the case, in the possible options. So if case equals classic negative, it's going to assign it to Dreamland. If it equals the film sim for Astia, it's going to assign it to Astia Pops. And remember, we said earlier that Acros and Monochrome do not write to the film mode flag or tag, so that's going to be blank, right? Very quickly, I can use the film sim to determine which recipe I used and then set the recipe and the URL accordingly. Very simple. If we had more tools or more values we needed to look at, then we could do that. But let's take a quick look at what this is going to do. And we're running script 3, and we'll run it against all of these files. You can see as it's going through, it's updating each of the files that we sent. And now what I should do is the next time I run the Exiftool command to print out the IPTC data, you should see more values. You should see hopefully all of them. Let's see what we've got here. IPTC. And there we go. We've got Astia Pops, Dreamland, and looks like maybe we didn't select any of that. Nope, there we go. So now we've written all 3 of those. And again, of course, we've missed a lot of files, right? I didn't select any of these. But you get the gist of it, right? So just that easily, just by creating this script that has all 3 recipes in it, I can evaluate the simulation, use that to determine which recipe I used, and tag the images correctly. And that's exactly what we're after. Now let's build on this a little bit more and just keep making this a rock solid solution. Right now we're sitting at the state where we're really doing what we set out to do, right? We've gone through our images, we've identified what the recipes are, and we've created some simple logic to look at what simulation was used so that we can determine which recipe information to write to the file. Now, let's take a quick look at something. In fact, let's just double check our work. And if I run the Exiftool command again, you can see I've got all of this data in here, right? So we haven't touched all of the files, but it's there. So I like to use photo mechanics, and so I've actually got it up already. And you can see none of the information. So there should be a film recipe right here under the exposure. So if I go in, I go to the information, I scroll down, and it should be appearing in the transref and special instructions. All right, that's where we told it to go. But you can see if I cycle through, the value's not set anywhere. But that doesn't make any sense because we can see the information here. The problem we've run into is that the way I have photo mechanics set up is it uses XMP sidecars. So XMP sidecars are a universal way for applications to transfer an XML representation, a common standard definition of the information that we're dealing with. So you have 2 ways of doing the metadata. It can be embedded, which is what we've done. We've embedded this into the file, but because PhotoMechanic is looking for a metadata sidecar, it doesn't know about that because we haven't created it. If I happen to search for let's see, pictures, Exiftool star.xmp, there are no there are no XMP files. So let's change our script to reflect that. So we're going to do this right now just for the Dreamland recipe, but this is one of those where I'll walk you through it, but I'm not going to, this isn't a Linux explanation. So I'm just going to kind of gloss over this, but suffice to say, the comments, you can read them here. What we're doing is we're grabbing the base file name without the extension. So whatever file you send in this case, we're dealing with Fuji RAW, so everything's going to be file name.ref. Well, I just want the file name without the ref. So I'm going to store another variable called base, and I'm going to use awk, which is a Linux program. I'm going to print the first value, and I'm going to pull that from whatever file was passed in. I'm going to create this XMP value, which is going to be the base with the .xmp extension. And then I'm going to use this tags from file. I'm going to use the original file name to grab the tags. And this is where things will get a little bit tricky, depending on how you've deployed. You should have, and I'll be honest, I couldn't find it when I looked in my local file system. Wherever you install Exiftool to, you should have an arguments folder, this args, and then there's a list of argument files within that. I actually got mine from the GUI version of Exiftool, so if you've downloaded that on my machine, it's in my home directory called JXFtool GUI data. And what I'm going to use is this IPTC to XMP arguments file. So this is going to help it do the file mapping from the IPTC data to the XML or XMP format. And then I'm going to save that as the file name that I created here on line 15. So now if I run this again, let's see, so we'll go back over here. Let's see if I can get rid of this. I guess I need a charge. And we're gonna, let's see if we can find Finder. We'll go through here. Let's pick a few more. We'll drag this across. Increase our odds of getting something with Dreamland. Now you see updated and created. So that tells me that it updated the metadata, and it also created an XMP file. So there's another one. So we've got a few in here that are based on Dreamland. We'll let it run a little bit. And when we're done, we'll check, verify that we actually do have XMP files created. Should be done in just a minute. It does take a little bit, so if you've got a huge image set, you'll want to take that into account. There we go. All right, now we look there, and now you can see we've got a handful of files that we've created XMP files for. If we go back over to Photo Mechanic, and Photo Mechanic sometimes needs a little kick to refresh it, so we'll just switch over, and it should. Here we go. There you go. All right. So now you can see our Dreamland is appearing, and this is accurate, right? It's only on those files that we selected. If I go back into the metadata panel, you can see, there we go, Dreamland, and there's the special instructions with the URL. And we're almost there, but the script is looking really good. But obviously we need to do this for all of the recipes, not just this one. So in the next step, we'll clean this up, we'll finalize our script, and we'll get it ready to rock and roll. Okay, so we're almost to the end here. We've covered a lot of ground. We started at nothing, but now we've got a really strong, viable script that lets us go through the three recipes that we used for this image series, and it can identify what simulation was used and therefore which recipe was used, update it, and now when we come back a year or so from now, we can easily look at the metadata for the image, see what we used. It's both embedded and available as an XMP sidecar. So whether you're using Photo Mechanic or Photoshop, Lightroom, Capture One, whatever, the data is available for you. So let's clean it up just a little bit more. When we left off, we'd only set up for doing this for one recipe, and keep in mind that what we've done can be used for all of your recipes, right? So the way I do it is I create, in this example, I created a file based on the simulations that I needed. So if I go out, I can do that for every scenario. I can, eventually you'll build a library of scripts, most likely, that have different recipes. And then you can just grab and copy and paste from one script to another to build whatever you need. Um, Again, if you keep yourself focused to just a handful of simulations, if you follow my example like I did here, where each of my 7 available custom settings is its own film sim, then that streamlines the process. I plan on doing an advanced series that if you're really nutso and you just go off the rails and you've got five different sims or 5 different recipes based on classic Chrome, for example. How do you identify between those? Because it can get pretty complex at that point. In this example, we're only looking at the simulation, but you might have to look at the white balance and the color temperature and saturation maybe, or the white balance fine tuning, whatever the case may be. So stay tuned for that. Hopefully we'll get that out shortly. But let's turn our attention back to cleaning this up. And one of the things I wanted to do is use a function, something again that I can use repeatedly. I don't want to have a bunch of code that I copy and I just copy and paste it everywhere I need it, because if I have to make a correction, as I'm testing this and I find issues, then I have to change it everywhere. So it's much easier to do it localized in one location. And so I took the logic that we used earlier to write the XMP data, and I created a function within my script called, oddly enough, write XMP. Pretty self-explanatory, but it does exactly what we did in the previous version of the script. The only difference here is after I get out of the case statement, so I've done everything I need to in order to update the recipe and the URL that it came from. Once I'm out of that, then the last thing I'm going to do is write that XMP data. If this isn't important to you, then you don't need to do this. You can just comment it out, put a pound or hash sign in front of it, and you're done. Now, the only other thing I'll point out here, if you've paid attention, in the last example, as it was running through, it would say image updated, image created. I don't really care to see that. I just want it to be quiet. So I've added this -q flag, and so that's going to put it in quiet mode. And I did the same thing up here. You can see it's in the XMP section as well. So now when I run this, I won't see any output. But that's it. I could run it again. I'm not going to because I have something else to show you as we wrap up. But that's it. We've got a very clean script here that, to me, it meets the task. It helps us permanently identify what recipe was used for every image. So stay tuned, and we'll really put a nice bow on this and wrap it all up. All right, so we've reached the end of the lesson, and now you've been able to go from a plain vanilla series of images to one that you've got a dedicated script for that can go through, iterate through all the images in the series and update the appropriate recipe information. But you can do this the way we've done it. You can run the command from the command line like we've done it. You can drag and files over from Finder into the command line and update it. But I think a little cleaner way and a better workflow is to make this available to other tools, such as Photomechanic. So if you're on a Windows machine, I apologize. Our journey here might be done. I don't know what your comparable solution for this would be, other than maybe making a batch file. I haven't used Photomechanic on the Windows platform, so you might be able to do this as a batch file. But what I want to do is use a tool that the Mac provides called Automator. And what it's going to allow us to do is to create basically a little application or a droplet that we can execute. And I can put this droplet on my desktop, I could drag files to it, but we're going to integrate this directly into Photomechanic. The first thing I want to do is I want to grab all of the content. So controller command A to select all, command or control C to copy, and then I'm going to fire up Automator. Now when this comes up, and go to the file menu, say new, and it's going to prompt me for what I want to create. I want to create an application. Choose that. And then it's going to allow me all of these options here. Well, I know that I want to create a script, so I'm going to just search for that. Run shell script, I'll double click that. And I'm going to expand this here. I actually use a different shell. So Bash I mentioned at the beginning is a shell. I use a shell called ZSH. So I'm going to switch this over to Bash. It's really kind of pointless here because I've got everything in my script, but normally I would say pass input as arguments. And this should look familiar to you. Let me see if I can't make that bigger, so hopefully you can read that okay. This is where I got all of that logic from to begin with. And I'm just going to do a controller command A again to select it and overwrite that with that last version, that version 5 of that script. I'm going to do a file save. And I've got a folder here called Exiftool droplets, and I'm going to call this Exiftool YouTube. And we'll save that. So now when I switch over to Photomechanic, let me just go into the preferences. So go to settings. And let's look at launching. And you can see here, Photoshop droplets location. And so I've picked that folder, and so it knows to always look at that folder for these droplets. Now, let's let's go down a little bit here. Let's see this. We'll just go here. All right, so we'll select all of these. And if I right click, off the context menu, I can select Send Selected Photos to Droplet, and these are all the droplets that I have. So we'll select Exiftool-YT. It asks me if I'm sure that I want to do this to all the photos. I'll click Yes. You can't see it because I'm not recording my toolbar, but I've got a little spinning gear, and so it's going through now, and it's executing the script that was in my droplet. So everything we worked on up to this point, it's now running through, looking at the metadata, figuring out which recipe to write, updating it, and creating the corresponding XMP file. So again, if you've got a lot of files, it's going to take a little bit of time to run. That's why I only selected a handful here. It just wrapped up. As you can see, nothing really changed here. So let's change focus here, come back, and there we go. So now we've got images here that were shot with Astia Pops, others that were shot with Dreamland, and others that were shot with the Leica M10 monochrome. And so just that easily, we've gone through and we've, in a very automated fashion, tagged all of our images with the proper recipes. So I hope this was helpful for you. A lot of people have been asking for it in several of the Facebook groups. It's been on my mind to do it. I've needed to work out some kinks and find the time to sit down and record it. If you found it useful, feel free to drop me a comment. If there's something that's maybe not clear, let me know that as well. I want this to be as useful as possible for you. That's it. Until next time.